Hello everyone, myself Sriram, studying from the GMRIT, and I am here to explain my project about washing machine in the embedded system internship. So let's get started. Today I want to discuss about C programming, microcontroller, microprocessor, and about washing machine simulation. Introduction on PiximLab simulator and its installations, XC8 compilers also, MPLAB IDE. C programming. C is a general-purpose structured and machine-independent programming language. This is widely used for writing various applications, operating systems, and complex programs such as Oracle, databases, GitHub, and Python and Proteus, and etc. Conditional constructs, single iteration, if else, if else if, and switch case, multiple, while, do while, for, unconditional continue, break. So, embedded C. Embedded C includes operators, pointers, strings, storage class. About microcontrollers, a microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. It contains three major components: processor, program memory, input-output peripherals. So let's discuss about processor. The processor is the brain of a device, responsible for processing instructions. Program memory, which means stores long-term information about the instructions the CPU executes. Data memory, used for temporary data storage during instruction execution. It's volatile and requires a power source. Input-output peripherals. This allow communication with external devices and enable the microcontroller to interact with the world. About microprocessors. A microprocessor is a computer processor wherein the data processing, logic, and control is included on a single integrated circuit or a small number of integrated circuits. All separate components, more flexible, more design complexity. The microprocessor contains the arithmetic logic and controls circuitry required to perform the functions of a computer CPU. It's capable of interpreting and executing program instructions, performing arithmetic operations, and providing results in a binary form. Embedded systems. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Categories: standalone, real-time, network, mobile. So, challenges in embedded system: efficient input-output, embedding in operating systems, code optimization, testing, and debugging. Real-time accepts. Hard real-time should meet its deadline life critical application. Firm real-time. Similar to hard real-time. Soft real-time can have tolerance in meeting its deadline. So let's discuss about the installation of MPLAB IDE. I have installed the following softwares: MPLAB IDE, PiximLab, XC8 compiler. So LED basic program demo. Basic LED program toggling LEDs connected to port B, PIC16F8778. This is the module which I have been used to toggle the LED and done my project, washing machine project on the same. Build hex file in MPLAB IDE software, then in PiximLab software load the hex file. Board PIC Genius board. Microcontroller is the PIC16F8778. MPLAB IDE supports project management, editing, debugging, and programming of microchip 8-bit, 16-bit, 32-bit PIC microcontrollers. It only works on Microsoft Windows, and we can install the Linux-based version also. PiximLab Simulator. It is a real-time emulate of development boards for code editing and debugging. The same tools used for real board should be used with PiximLab, such as MPLAB Pix or Arduino.ide. XE8 compiler is a compiler from Microchip for 8-bit PICs. Both program runs on Windows, Mac OS, and Linux. This is the PIC Genius. This is the microcontroller with which I have used it for my project. It is a 40-pin microcontroller designed using RISC architecture manufactured by Microchip and is used embedded projects. It has 5 ports on it, starting from port A to port E. It has 3 timers in it, two of which are 8-bit timers, while one is a 16-bit. So this is the PIC16 F877A board, and this is the architecture. CLCD, Character Liquid Crystal Display. It has two types of display. They are 16 into 2 and 16 into 4. Use it to display all ASCII character and symbol. It has totally 16 interfacing lines. D0 to D7 are data transfer line that controller can execute the instruction and data. Tactical, tactile switches in matrix keypad. We need to configure rows as output and columns as input. While designing pull-down interface, R1 is 10 times greater than R2. Triggering methods: edge trigger, level trigger. Bouncing effect: there is a metal plate and terminal. Suppress pulse detection while pressing or releasing the tactile switch is called bouncing effect. Now you can see how washing machine simulator works. Powering on of washing machine. Washing machine is an on mode. Select the washing machine program. We need to select the washing machine programs like daily wash, heavy wash, delicates, etc., which we have been programmed in the code itself. Select the type of clothes, and we need to select the water level also, and start and stop of washing, and setting the washing time, starting the wash. If door is open, buzzer will make sound. After completing the wash, display will print the message as remove clothes. So these are the images of my washing machine project. So in conclusion, this will discuss after showing the washing machine program demo. So this is the MPLabX IDE. In this we need to be code and we need to run the program itself. After doing the program and after running it successfully, so it shows build successful, and then here I am loading the text file again. So here RB0 is the first switch, RB1 is the second switch, RB2 is the third switch, and RB3 is the fourth, and RB4 is the fifth. So press key 5 to power on washing machine program, and I am selecting the daily for the demo purpose, and I am selecting the material type. So we need to long press to select the water level. So I am putting it as low. High. So To start the wash, press switch 5. So if we open the lid, the buzzer will make noise. After completing the 16 seconds, it will show the remove clothes. So successfully the wash has been completed. Now let's discuss the conclusion. It should summarize the key findings, outcomes, and implications of the project. In conclusion, the washing machine project has successfully achieved its objectives of designing, developing, and testing a functional washing machine prototype. We have created a product that not only meets industry standards but also incorporates innovative features for enhanced user experience. Throughout the project, we addressed various challenges such as optimizing energy efficiency, ensuring water conservation, and enhancing washing machine performance. In these areas, making our washing machine not only environmentally friendly but also highly effective in cleaning clothes. Additionally, user feedback and testing played a crucial role in refining the design and functionality of the washing machine. There are opportunities for further refinement and optimization, particularly in terms of reduction, scalability, and incorporating smart features for connectivity and automation. By continuing to innovate and collaborate, we can further elevate the performance and efficiency for our washing machine, making it a staple appliance in households worldwide. Overall, the washing machine project has been testament to our team's dedication and commitment to creating sustainable solutions for everyday challenges. We are confident that our product will not only revolutionize the way people do laundry but also contribute to a cleaner and more sustainable future. Thanking you. I hope our project will help you. If you have any doubts or queries, please drop down in the comment section. We will try to rectify it. Thank you.